Yeah, a little bit more with my experience. I got into Python. Python's great, and then during my day job, I was using Databricks. Well, actually, before that, I was using a little bit of PySpark. Here and there, but it's free because PySpark is free, and I'll talk a little bit more about that in a second. And day in and day out, PySpark or Apache Spark has become one of the industry standards when it comes to data processing. And if you're in data engineering, this is definitely a tool you want to have under your tool belt. Right? There's also other applications, modules that are out there. There's Polar and there's other different things that you could make yourself familiarize yourself with. PySpark is distributed. It does distributed computing. It operates on clusters of machines, and I'll show a diagram here in a second where it works on different cluster managers where it moves tasks to worker nodes, and those worker nodes work through memory and maximize the use of your computer to process your data or whatever task you have a lot faster. All right. So it's the key thing with PySpark or Spark in general is speed. So when you're working in the Apache Spark environment, it's usually you have different options to work with. Yeah. So today we're going to talk about PySpark. Again, I'll show you some SQL, that option there. I'm going to talk about RDDs, which is the foundation of Apache Spark, and then we're going to talk a little bit about DataFrames. So DataFrames, you're mostly going to be working with DataFrames. If you're in that sector, working with PySpark, RDDs is mostly used for situations when you're working with unstructured data. So that's what's there. Okay. Yeah, so I'll talk a little bit about this here. So we have, there's different options within your PySpark environment. You have, this is a little bit outdated, sorry. So you have MLlib, which is a machine learning module that you use within PySpark to process or perform machine learning tasks within the Apache Spark environment in Python. All right, so you have that option. There's also in Apache Spark streaming, GraphX, SQL. So I found in my job that using the combination of SQL and Python helped me perform my task a lot faster. And I definitely recommend SQL is not going away. Still learn it. It's great. And it helped me out even today. It was like, oh my gosh. So anyways, this is the bare bones of what Apache Spark is doing is right over here, this diagram on the right. So we have instructions that's being sent to the driver program. That's being sent to the cluster manager. Cluster manager breaks up the jobs, sends that over to the worker bees or worker nodes. Worker nodes work off the memory of your computer, and then it processes the data and then brings it back. Right? So that's like the bare bones. You had a question? You had a question.
So what is Spark? Just why would I use Spark? What is Spark?
You want to, so if you're in an environment that you're working with data sets that's super large, millions or maybe terabytes of data, and you have either normal routines or a complex set of routines, and you need your time's ticking, you want to use Apache Spark because it'll help you reduce the data processing time for your day-to-day work tasks.
So is this reporting or transactions?
Both.
Or? Okay.
Yeah, both. Anything. Reporting, transactions, anything. Yeah, and amazing. So it's free, but there's a catch. Okay. All right. So you have for Windows, and this speaking for Windows, you can install it into Mac, but I'm not familiarized with that situation. Your computer needs to have a sufficient amount of memory and CPU power in order to run Apache Spark. So just to keep the story short, I was wanting to give this presentation before, but my laptop that I was transferring my Apache Spark into was super basic, didn't have the memory, CPU was very clunky, it just did not work. Right? So what I did, I got a powerful laptop computer. So I spent some money, and then hey, all right, we're working. So here are some of the basic requirements that you see here. I'm also going to pass around this piece of paper that does have that, so you can share that, keep it, or anything. So you want to definitely have, if you're doing like, if you're performing tasks that you're just learning, and nothing too complicated, maybe consider something around an i5 for CPU power. Do not go below i5. I strongly recommend do not go below an i5 when you're working with Apache Spark. And I'm saying this because to save you money. Because if you buy a computer and then you have that computer just to use Apache Spark, and it might not work. And that's the problem. And that's yeah. Luckily, I didn't run into that situation, but I had my old computer, thought it would work. It didn't work. I had to go a higher computer. Yes?
This is just for learning a question. You're talking about when you're running it locally, it's running on different cores. You're saying
Yes.
cores. So it's like concurrent on your, versus like in a production environment, you're running on actual different machines, right?
Right. So it's on your cores.
Okay. So yeah, for like smaller data sets,
Yes.
you're saying it's good. Okay.
Yeah.
Yeah.
So, yeah. You definitely want to have a lot of RAM on your computer.
Yep.
And Java. So Spark runs off Java. You want to have a Java 8. So here's the thing with Java, and this was another obstacle I had to overcome, and I'm happy to provide you this education. Oracle owns Java. They don't have Java 8 like just available for you to download. So they have the more other types of versions of Java that's available for you. And if you're trying to get Java 8, you're going to go through a lot of obstacles trying to get a hold of that software. I got like a weird version of Java. I got Java 11, so my Apache Spark is working on my computer, but Java 8 is what's recommended. And actually what is in some of the industry standard applications that use Apache Spark, they use Java 8. Okay, Java 8 that's the way to go. But right now we have Java 25, so it's like, right? And then Oracle controls everything, and then you try to get a lower grade of Java, you're not going to get help unless you got, right? So, anyways.
I'm sorry.
Mike, do you know if it matters with do you need a JRE or JDK?
Oh, you need a JDK.
JDK.
You need a
Will
JDK.
Spark run on Java 25?
No. It's either 8, 11, not 20, 25, no. I mean, you could try it.
Okay.
Yeah. And if you have luck, just let me know. But yeah. So here, you have a question? No? Okay. So here are some of the main things that you need to have for your installation. So I'm not going to spend too much time on this. There's a lot of information on here. There's a lot of information online that's related to what you see on here. I do recommend that you use ChatGPT or some sort of AI chat to help you come up with a more refined and focused set of steps to do the installation of Apache Spark. And oftentimes, either ChatGPT or anything else is going to tell you Java 8. But you definitely want to have the latest Python. You want to utils download. So utils is associated with Hadoop, and so Apache Spark is built off of Hadoop. So that's another thing with that. You definitely want to have the latest Spark download. There are documentations online, and you could definitely sit and read through all that. But there are options for you if you want to get yourself moving. There's some online, so some of the online sources that are out there, be wary of it. Some of it is junk, but some of it is good. Yeah, so just be mindful. Yes.
Curious if installation is such a problem, have you used a Docker container?
I was exploring that recently to use a Docker container, but I didn't get to that point where I was able to get everything booted and then prepare for today. That Docker container
That's
is an
another
option.
avenue to.
Yeah, that is an option.
Yeah.
Yeah.
Somebody else has solved all this problem.
Yeah.
Right. Yeah.
That's where I'm
I am
going.
looking, so for anybody curious, there does seem to be a Spark Docker image that might make, or if you're already comfortable with Docker, it might make it easier to get going.
So let me see here. Just want to make sure I'm on track. All right, yeah, so here are a lot of the features in this slide of what you can expect from PySpark. So in PySpark, you do have the DataFrame environment. So this has actually been around for about 10 years-ish. So Apache Spark has been around for 15 years. 5 years after it first came out, they started implementing some new features into Apache Spark where you can use the data frame, because it first started off with RDDs, and now it's the data frame format, the tabular, rows and columns. So make it easier for data processing and data handling. You also have options with Pandas API where you can use Pandas functions that in your Spark environment. Also structure and streaming, and machine learning as well. So next we have the bare bones here is the RDD for PySpark, and I'll demonstrate that here in a few minutes after we get through these slides. So definitely RDDs, these are the very basic, the fundamental data structure used for data processing in Apache Spark. And some of the key points here, it's it's in memory, can store any size of elements. It's when you're using RDDs, which hardly anybody does, but it's mostly used when you're dealing with unstructured data, right? Or RDDs. Next, there is lazy evaluations. So lazy evaluations is also seen in DataFrames. So what that means, that concept is that a particular action you run a function, it performs a task to transform the data into one aspect to another. That is stored in memory, right? It's transformed. And then but what's happening, we have lazy evaluation. So nothing has really happened yet. So it's taken its time, right? Until you perform an action. And then the action, it could be like you're writing the table or you're displaying a numerical value. That type of function is called, those are usually called actions. And what happens is when you run the function initially, if it's just transforming the data, it's not going to give you the output right away. And that's what they mean by lazy evaluations. So I hope that was clear.
That was something that I found a little tricky to get used to.
I recently found this out 3 days ago in my work process, but I'll save that to the end.
Because if you're used to SQL, everything just happens when you send the
Right then and there, right.
But the beauty of it is that the lazy evaluations is that it kind of queues all this stuff up.
It does,
And
right.
then when you go to say return data, it can optimize what you've sent better because it's now, it's got a clearer picture of what you actually are trying to do.
And it's also saving you time.
Yeah.
When you're
you
running,
don't really do all that until you really need to
Right.
pull something back.
Yeah. So
Like in web framework world, your object relational mappers, many of them will do the same thing, where you put together your query and you keep chaining on the filtering or selection of whatever you need to do. And it's not until you ask for the actual result back, then it's like, okay, now you need to go actually do the SQL query.
all right. Okay. So let me go ahead and move on. So DataFrames. So this is another feature. This is what everyone uses. Right? When you're working in this environment in Apache Spark, typically people are going to be working in DataFrames because it's just like Python. Right? And it's fine. Just keep it simple, right? And so it still has the lazy evaluations feature when you're working with DataFrames, right? And as you're using different functions, it's not going to perform an action right away, displaying results or doing something, but it is going to queue up a particular task, like changing the data from one format to another.
I have a quick question.
Yes.
Doing the lazy evaluation, does that imply there's an audit of the data to see if it's valid?
Oh, like the tasks that's happening? Yeah. But that's a lot of that's happening in the background.
Okay.
Yeah, you're not gonna really see all that. That should work. Okay. Yeah, and so DataFrames obviously is for structured data, and that's that's all about there.
You know, one thing I'll just,
Go
for
ahead.
those who've used pandas, it's similar to the pandas data frame, but it's not identical. So,
Right.
and some of the operations are the same and some aren't, and it's
So-
a little bit,
Oh,
it can throw you off a little bit if you're thinking it to operate exactly, because it's not exactly. It's,
Right.
Yeah.
And I'll show everyone here about that here in a second when we get to the code. So the code is good. No, it's okay. Thank you for chiming in. So the syntax in PySpark, it is different compared to your regular Python coding environment. So some of the functions could be for a lot of the different tasks. The functions are slightly different. It's not completely alien. It is slightly different, but it doesn't. If you've been coding in Python for some time, it doesn't. It's not too hard to get used to. Right? So it's, yeah. Okay. Yeah. So with the commonalities here with RDDs and DataFrames, they both have these two types of features. We have transformations and we have actions. We talked a little bit about that already. Options, transformations are operations that reads in data, manipulates it, and returns it to another format, which will be eventually presented to you later, which is the lazy evaluation part of it. Right? Then you have actions. So these are operations that either return the result or write it somewhere. Right? And that's what actions are. Okay, so we have, I'm on some of the slides here. So yeah, just a little bit of history. RDDs came out first, and then we had the DataFrames that came out a few years later. So all of this was just to help everyone, or help Apache Spark be more accessible to everyone, because everyone's using different DataFrames for their work tasks and different things like that. You can still have the features of creating user-defined functions in Apache Spark. Yeah. And so data representation, as we see here on the slides, RDDs is a distributed collection of data elements without any schema. DataFrames, it does have a schema. With optimization, there's no built-in optimization engine for RDDs. And for DataFrames, it uses a Catalyst optimizer for optimization. So there's optimization. If you're working with large amounts of data, this topic is very, very important. If you know how to do optimization pretty well, you will be very valuable at your job. Yes.
So are people moving away from RDDs to DataFrames?
People already been just focused on DataFrames, but I'm just presenting to you the features here.
Okay.
Yeah.
Okay.
Yeah. So like if you go in your job, let's say you're using PySpark, or it could be what's the one for R Spark R or something. Any version of Apache Spark, you're gonna see.
Would there be legacy RDDs?
Probably old code with Scala.
Probably with Scala, yeah, because that's what I think originally came out with Scala. Yeah.
It'd be pretty old now, yeah.
Yes.
Are you familiar with H2O Spark?
I've heard about it. I haven't used it. Okay. Do you have anything to say about it, or? Oh, okay. Oh, you're curious about? Okay. No, I haven't. All right, and so PySpark, we have the availability of SQL syntax and making SQL queries, just like how we know it to be in other different applications. The same here in Apache Spark. And yeah, SQL's good. And we also have options to different modules to perform tasks to help us with machine learning, and that's also available in PySpark.
You know, one thing with the SQL, SQL's like making a comeback, right? With
Yes.
stuff. And but one of the things that's cool is that whether you write SQL or you write it in Python, it all gets converted to the same thing under the cover. So whatever you're comfortable with, it ends up optimized the
It's
same
all
way.
DataFrames.
The underlying code, the Java code, like bytecode gets converted. It all ends up the same. It's just that is abstract again. Yeah.
Okay.
And you'll see a mixture of styles, right? Some people like lean on the SQL stuff if they're familiar with that. Others lean on the Python-centric coding. It kind of goes both ways, you know. Like in a lot of the SQL code, it's like an embedded text. It just gets passed in.
Probably if you have a data analyst or a data engineer background.
Well, and I know like Databricks, they really emphasize in their implementation like exactly that. Regardless of your role, we have a place for you. Yeah, that's one of their selling points for sure.
All right. So at this point, I'm going to bring us into our demo, and I'm going to switch screens here. Okay, so what I have open here is my Anaconda Cloud environment, and this is allowing me to code in PySpark and show you some of the different things that I just talked about, right? RDDs and DataFrames. So at the top here, so this it took me a lot. This is so Apache Spark is free. You can put it on your computer, but get it to work. Hey, that's some tough stuff. So I managed to able to do that, right, at a certain point, right? So what we see up top here is just some modules to help us get going with our environment for PySpark. So in the first couple modules, we see the OS module, the system module. That's to help us with in our environment, and mostly to help facilitate PySpark to do certain things. And next is import find PySpark. So the one thing when you're installing PySpark, what you'll see is you have to configure your environmental variables on your computer. And sometimes when you configure it on your computer, it's not the right folder name or something to that. So they have different modules that to help you find PySpark. So that's what they have. They find PySpark module here, or find Spark module here, and we initialize it and we get this going. Yeah, import Spark.
Does that init just make sure that Spark is running somewhere that's successful? Basically?
This is, but what we're seeing up top here is pretty much to say, Spark, where are you?
Where are you installed? Where's your config folders?
Exactly. Where are you, Spark? I need you here. We need to. Somebody wants to use you. Yeah. So this is pretty much what's happening at the top here.
Okay.
So, yeah, it's but there's an easier way, which I'll show you at the end. Okay. Google Colab.
Cool.
Yeah. And so what we're seeing here is my attempt to optimize my coding environment. In this particular demonstration, I don't think I really needed to do all this because what I have is really like some simple data sets. But there are options. I'm just showing you this, that there are options to optimize your coding environment, meaning that to help your PySpark session move a little bit faster. And some of the things that I didn't mention earlier, which if you do take a tutorial, you might find out, is that when you're working with the, let's say the master cluster, or the aspect of your computer that disseminates the job to the worker nodes, it has a set of instructions for it to determine how to distribute that work to the worker nodes. But you can set those parameters automatically in the beginning of your environment. And this is my attempt to do that here. So there are options for you, and that does make your coding experience move a little bit more faster. So there's options there. All right. So I have this is what helps Spark go, initializing your session. So we're bringing in from PySpark, we're bringing in the Spark session module here, and here we're creating. So we're creating an app. So there is actually a feature where in Apache Spark, where there's an application that will show you the speed of your coding environment through a different browser. But I was having trouble to bring that out here, but you can do that. And this is part of that. So here the app name. So this is what that actual browser would be called if I was able to demonstrate that to you here today. All right. So anyway, so this is how you get started with PySpark. Okay. Yeah. So we're down over here.
Now, one thing
Yes.
I found with this whole setup thing, once you kind of get it figured out the first time, you just copy and paste it every time. You do.
Yeah.
It's
Right.
The hardest is the first time.
Is a Spark process like already running, like it's a client server model, like you're connecting to something, or does this?
Well, if you're running locally in a dev, it's not. Right. But if you have a cluster that's up somewhere, that's a different.
It's waiting for instructions. It's got
That's a different
executors
thing.
already running.
And you're just creating a session to it. But like I think like in this case, it's not running till you start it because it's
Oh, okay.
the first time you get it. Does that make sense? It makes sense.
Yeah, it's in the back.
Appreciate it.
Okay, so I created a set of numbers here. So what I'm doing in this cell, I created this list here with this set of numbers, and I'm transforming it into an RDD, and I'm performing some calculations here. So we have 1, 2, 3, 4, 5, and I'm just putting it through here, and I'm just getting the result here, 1, 4, and we're just squaring it. So yeah, 9, 16, 25, and so on and so forth. And I'm printing out the results here. And this is another attempt to do that. So here, again, the feature with RDD is unstructured. Right? So that's the signature type of feature that you would see with RDDs. And there could be different applications that type of that you can use RDDs for. Lots of unstructured data out there. Yeah. Okay. And we'll do some calculations here. Yeah, we just capitalize everything. And yeah, put the upper.
So the process is like the cluster manager is taking the bits of data and
Yes.
chopping it up and
Sending it out to the
sending
worker
it out
nodes.
to a bunch of worker nodes. Okay.
Well, and there's the driver. I like that.
Yeah, the driver,
The
yeah.
driver, right?
The
So
driver,
that's
right. That's the name.
That's like the visual architecture there. And then the worker comes out here, and then the driver.
The driver kicks it to cluster manager, which then distributes.
And then the worker nodes work off memory.
And then they return it back, and then the driver will send it back to.
Okay.
So my thing is with computers, if you get a gamer computer, then you're pretty much kind of safe to work in. Yeah, seriously.
And you can play cool games in your free time.
Yeah. Well, yeah, that too. If you have the space, but yeah. So yeah, we got just showing some different functionalities here. So I believe I have this data. Do I? I think oh, I do. Okay. So I bring in this heart.csv to my environment, and let me see here. All right, yeah. So heart CSV. So I'm checking here the data types, and so we see this is something that you probably would not see in Python. You have like string types and this kind of notation. So obviously here is telling you the type of the data types here are string. So it's a little bit different. It's not like totally foreign. Let me see here. So at this point we're working with the Heart data set. I'm just looking at the data, checking the data type, and different things like that. And there's also options here for us to do some different things. Yeah, replacing null values with NA. And that should be. Oh, and another thing, when you're displaying information, oftentimes in the PySpark environment, you're not going to get everything. So what it does, it'll give you a preview of the data that you have in memory, but it's not going to show you anything until you explicitly like perform an action. So that's another thing when you're looking at output in your PySpark environment. Just know that oftentimes you're not going to see everything, and some people get hung up on that. They think they're supposed to see all of the data all at once. That's not the case. Sometimes, especially sometimes you're not going to see everything.
There are some parameters like on that print. You can tell it more rows. You can.
Oh yeah, you could add more rows too. Yeah.
But you'll appreciate the default when you're working with a gigabyte file and you're like,
Yeah.
Right.
Now
It's
you
not
gotta go back.
scrolling for 10 minutes, you know.
Yeah. So, okay. So I'm going to move into DataFrames. So we have this. Let me go back up here. So we're putting our information into a dictionary type format, and then we're using this here to create a data frame. And here are some arguments that is that's part of this function here. So we have column names. We could put the schema for columns, for the column names, and the data is the data over here, and we transform it, and it's down over here. But obviously I'm not displaying everything, just a few rows, just for this demonstration here. And we're also getting when we put the print schema, we're seeing some good information here. Some working with wanting to see the column name, data type, and different things like that. And I'm going to go to Excel. And here I am getting this data here together and creating new data frames. Also performing a union, and also this is very important. So when you're appending tables together in PySpark, you have two different functions. You have union or union by name. Always go with union by name. I learned this at work because union is just going to append the table how it is. So let's say you have 5 columns, but it's arranged differently, and you go to append it, then you're going to have, let's say, age variable having names on the other, like at the bottom of your appended table. So union by name will tell PySpark to append a table by the column names. So you got to ensure that all the column names are there. And so if you don't put the column names, it will just do it on its own. And I got hung up at work. So I have a story about that, and I'm going to talk about it now.
Do you know what happens if the names do not match with each other? Will it just give you an error? Like, I assume it's like you have 2 different frames. One has first name with an underscore between it. Like, would it just kind of say, like, I don't know what to do?
Right, I think it would give you an error. No. Let's see here. Here.
It's either that or it'll list them separately as 2 different columns. Like
okay.
One with all
Make them
these with all
separate.
nulls.
Uh-huh.
I feel like that sounds.
Yeah.
If I remember.
So we get the hint here. We're able to create some data frames. So in this feature here, what we're doing is we're creating a new variable. We're using this function here with column, and this allows us to do that. Also, there is this. I think it's a function column. So this is this is a function, and this is what. And let me run this, and so and I'll talk about this here in a second. So this is a tip. Definitely, if you're using PySpark. The COL function, this will allow you to use column names that doesn't have an underscore with it. So let's say you have a column name that has 2 words. Now sometimes we run into those situations, and depending on the application that you're using, it doesn't like that. It's not going to treat it. It's not going to give you a good coding experience. So you need to fix it. But in this application here, you can use the COL function to allow you to use a column name that has something like 2 words in it. So that is an option if you choose to use it. So I run into this a lot. So yes, go
Like I
ahead.
say, with column, like for the SQL people, this would be like the equivalent of like a calculated column.
Yeah.
Right?
Yes, right,
Yeah,
Yeah.
when you're coming from SQL, you're looking for equivalents, right?
right.
Like what, and then once you start seeing those, and there's some guides out there that will like show you like if you need to do this, if you know SQL, how do you do it here? Kind of the single canvas, right?
Yeah,
So
right.
imagine too, like the with column. That's when you talk about transformers and actions. Like the transformer here, or transformation is the when adding derived, and it's not something to call a
It
show.
doesn't do it exactly.
That's
Right.
Just set it up. Just set
This
it
is
up.
the action here,
Yeah.
and this is just being transformed. All this is being transformed.
Yeah, you could have 100 other transformations
Yeah.
happen, which you would a lot of times, right?
Yeah.
Whenever it gets to the show, yeah.
So I recently found out that I would do a lot of a lot of transformations in my initial coding experience. But once I understand how the script is running, I take all that stuff out, so that it will just run faster. Yes.
Instead of assigning a string value, can you actually like call another function?
Call another function.
So
What do you mean,
so-
like up top here in the import?
No, like it looks to me like you're assigning child, teenager, or adult to life stage.
Yes.
So it's an assignment.
Yeah, this is a conditional statement. When.
Right.
Right.
So I've had a situation where instead of having a string value like child, I then have to go and run a function based on that.
using the one that applies
So
to each row.
I named the function and then it went off and it ran that function.
Oh, okay.
Mm.
That can happen. You can do that, but I'm not showing that here.
Okay. I'm just wondering how you're saying nest functions like that.
Right. You can do that. But just a tip: within the PySpark environment, it's not. And when you're optimizing your coding environment, user-defined functions are not the way to go. The best thing for you to do is to use the built-in, the canned functions that they already have in your PySpark environment. But if you have a routine that you must create a user-defined function, then you need to do that. You need to do that.
That's for speed. Just-
For speed, right.
Otherwise,
Speed.
you're gonna be calling the.
Yeah.
If you pass on lambda and it calls it 1,000,000 times for every row.
Exactly. If you're back, it's
Yeah.
just easy to use that.
But great question, yeah. I'm glad we're talking about these different things. Let me see here. I got a warning here. That's okay. We're doing some calculations here. Yeah. So we're just pulling in the old data and we're showing it over here. And we're doing like the average age, average. Yeah, so these are aggregation types of, group by. Group by is like, yes, very, very valuable when it comes to doing either data checks or analysis. Group by is the way to go. Thumbs up. I use that all the time, day in and day out. What's good? Okay. We've been doing a lot of this here, so. All right, so wait a minute. I do want to come here and let me see. So we did this. Go here. Yeah, so these steps here is going to lead us into the SQL experience here. So when in your PySpark environment, sometimes you have to, well, no, not sometimes, but you need to explicitly use a particular function to start using SQL syntax in your environment. So here in this example, different platforms does it differently. Let's say if you use Databricks, there's a in the cell you have the capability of setting the cell from Python to SQL, and that's very, very convenient. Here, obviously, it's freebie. You have to do something else, right? So here, we create or replace temp view. So this is actually bringing our coding, our session, our experience here to allow us to start using SQL syntax. And so here we're in the, for the DF object, we're just going to do some basic stuff, select everything from DF. And we want to show the first 3 observations. And then down over here, same thing, we're doing some other things. So this is so you can use SQL, but there is some additional things you need to do to allow you to to start using the SQL syntax or the SQL functions. All right. Next, I'm going to show a little bit of using PySpark's ML modules. So here I just loaded in, and hopefully I have my stuff here. Let me see if I still have it here. Yeah, okay. All right, so at the top here, in the cell that I have highlighted, I have several different modules that is specifically related to PySpark to allow you to perform tasks related to machine learning, different tasks. And there's a whole bunch of them that's out there. Feel free to explore more. I'm just showing you the very basic, bare bones of what you can do. So here, so there are there are some modules that doesn't have everything. So this is why you're seeing that I'm pulling in a lot of stuff, like vector assembly. This is for more like handling different columns, and regression evaluator. This is more for providing you with your evaluation metrics from your models, so you can see and can judge which model is the best to go with. So this is what, when we see evaluation, these different things. So, So again, the point is to allow PySpark to give us more speed and power to help us process data that we want to put through an AI model, machine learning model, at a faster rate. Right? So some models may take a long time for it to process, and with PySpark, the opportunity here is for us to reduce the amount of data processing time. And if we reduce the amount of data processing time, we're reducing the amount of time we need to be at work doing that kind of stuff. From 8 hours to maybe 8 minutes, you know. So just grabbing some column names here, and there's additional features over here. And so this is giving me some warnings here. But this is doing what it needs to. Yeah, and then we got our data over here. And so that's very basic on the machine learning side of it. And this is just a regular linear regression model. So, but you can do this all in PySpark here. Okay, so what I did, I stopped my Spark session and cleared my cache. That's a background there. Any questions so far on? So I went over RDDs, DataFrames, looked at how to get into SQL experience, and also machine learning options.
So can you work with unstructured data with DataFrames, or do you have to do something before you can get to the data frame? Or?
So it's when I speak to RDDs and DataFrames, so these are the data type objects that we're working with in our session. Right? So you can change the RDD into a data frame and
okay,
this kind of
I
thing.
see.
Yeah.
Okay.
But you can also have an unstructured, effectively unstructured file inside a column, right? That's just indexed, and then you pull it out, and if you destructure it, right, then you,
Yeah.
in a data frame, it could.
I see, yeah.
Yeah, that's right.
Yeah.
So it's, and that's very often done, right? You're just reading in files, right? Say file processing or something, and then you pull it out from there and do more with it downstream.
Because you'd have to be able, I would imagine, having not, keep in mind, I don't have any experience with this, but I would think you'd have to be able to like convert an RDD into a data frame is basically a table, so it
Right.
has to fit into a
Columns and
tabular
rows.
format
Yeah.
to use it. So if there's some part that's not going to cleanly map, like maybe you have a really complicated natural stuff, like unstructured data in your RDD, then you'd have a problem like
Well,
mapping to it.
and I think, and everything is an RDD at its
Yes,
core.
at its basic level.
It's always, RDDs
It's
are
always built
there. It's
off
just
of
the
RDD.
data frame
yeah.
wraps around the RDD
Ah.
to add more context and structure to it, you know, like the schemas and stuff, yeah.
So I do have
Frames
a,
it, if you will.
yeah,
It frames it.
yeah, sort of, yeah, yeah.
Frames the data.
Yeah, or provide more structured context. So I do have a short story of what I ran into, kind of related to your question, friend. I had a situation where I'm processing data and I'm using the data frames, but I came to a certain point where there's some functions that I couldn't put a data frame through, and I had to convert it. And I actually had to convert it to something that's really similar to an RDD. And in order for, so this was like this was a function that I used to select certain records from fields. And so I was using regex and some other different complicated things. But I couldn't use a data frame as part of that function to help me find the records. So I had to like convert it into something else.
It's also very JSON native.
Yes, right.
which
Very,
is
very JSON native.
everywhere now, right? So
Yeah.
that's very commonly, you know, JSON files, if you will, or structured come in, streaming from some emitter somewhere.
Do they have some method to flatten a JSON structure?
There's methods in there. Yeah,
Okay.
yeah, it's pretty native stuff. And all the Python stuff is available too.
Yeah.
It's,
Yes,
I had a question about actions. We talked about actions, but for demonstration purposes, everything was a show, right? So you could display it in your Python notebook. But let's say your boss came to you and said, you know, out of all of our employees, we want to find people who are eligible for retiring, for example, and provide that as a CSV. And so you come into PySpark and you write some cool SQL query to extract those people. Can one of the actions be to dump that data?
Yes, that would be an action
That's also an action.
to write to CSV.
Yeah. Can you, do you know any other actions that? You know,
Yeah,
people
displaying
do?
information, showing
Display.
information. That's
Yeah.
that's an action as well.
you can
Collect
there.
is an action as well.
Yeah, okay.
It's basically, it's any, command that basically has to go out then to the worker.
Yeah, it has to go into memory
and
and
grab
pull in
and pull
information.
it actually.
Yeah.
As soon as you
move
actually
data.
need that answer.
Move data
Right.
somewhere is what, yeah, right.
Yeah. Okay, thanks.
I was wondering about the aggregates. So,
Yes.
like, I can fully understand when you have a bunch of worker nodes and it like the cluster manager figures out how to distribute the data out to work on separate chunks. That part's no problem. It's the aggregate piece of like something has to do that aggregation eventually. Like, so do you know where the aggregation would be processed? Does that question make sense?
I think back to the driver.
Is there like a main node where that happens, like a?
So I heard you mention that. So there's this concept of wide and narrow transactions, or is it transformations. A narrow one is an operation that can occur on one worker node. So all the data is there, and it kind of knows where the data based on its, right. But then a wide, so group I is typically a wide because data's all over the place, probably, right? And so it can then, it's less efficient for one, just because of the nature of you gotta go hit more nodes. But it will grab the data it needs, it figures out what data I need, and then bring it back to some node to work on it,
Right.
to do it.
So one of the workers is also doing aggregation
Yeah, I think that's what
like
the
from
conference can do.
like a development model. It would seems like you pretty quickly overload a driver node. Like you would want that. I'm thinking of like the driver is like the control plane where you're
Yes, the
issuing
controller,
commands
right.
and, like, you
Yeah.
don't actually want to.
Well, it gives assignments. Yeah, assignments and commands.
Right.
And even like workers, yeah, it can divide the work up
Right.
as it deems most efficient, right? So in a group by operation, maybe one worker's working on part of it, another one's working on part of it, and then they can merge them. And I mean, that's the magic
Yeah.
of having some of the covers, right? Yeah.
Cool.
And something I really love about Databricks is that they show you the number of workers that you have
Oh,
available
yeah.
in your
There's
session.
a lot of metrics.
Yeah, there's a lot that is that's in the background. But
Yeah.
yeah, go ahead.
I could say Spark has that too, but it's not nearly as intuitive to see. And
Right. So the app helps you see all that. So the app is something I'm not demonstrating here, but you can have the app in your coding experience. It does take some work. In Google Colab, there is a way to get an app. So the app is actually just a browser that shows you your session's computational metrics, like what's happening, how much time you're using to process data, each step, and all that.
It's like a graphical
Yes.
application for PySpark?
Yes,
Yeah, okay.
exactly. Yes.
It just shows you like your nodes, what it's utilization. Okay.
Yes.
Utilization.
You gotta justify why you get that big bill later.
Right, you're like, well, here's a screenshot.
well, and to help you then, you mentioned optimization. Yeah, if you get good at that,
Yeah.
that's the magic.
Yeah. I'm getting there, but it's.
I was wondering how you visualize that.
Yeah.
Like all those processes.
Yeah, it's the browser.
But that's to his point about aggregation, like how that's visualized. Okay.
Yeah.
Yeah, it's got a whole optimizer engine.
To that point, will you put that configuration at the top, just like when you started at the beginning of your session? So in the instructions, you want to take the result of a data set, like we were mentioning in terms of people that are ready to retire. So you want to have, can you tell PySpark to display in a browser those results?
Oh, right. So yes, you would do. So for the app, you would do that at the beginning.
At the beginning?
Yes, at the
Okay,
beginning.
so you put it-
So, I'll show you where you're supposed to do that. Where is it at? Here we go. Ooh, no.
Well, just like an HTML page. So you put certain
So,
instructions right there.
Where's it? Aha, here we go. So I'm definitely not showing this to you properly, but here is an example of where you would create the app name. So this is where the app stuff is pretty much made, is when you're doing the Spark session function. And here, Spark session builder, and then here we have the option, the arguments, put an app name, then configuration here. This is where, so Google Colab makes it very difficult for you to display the app for your environment experience, but I do invite you to still try. You can do it. There is some effort involved in this. Get the port for your computer and all those, but you can do that, yes. And this is where you would do that. And you want to do that in the beginning. Yes. Thank you. Okay, so I do have a, can I continue? Is that? Okay. So what I do have here is a Google Colab browser that's open, and to share with you something I didn't know about 8 months ago is that you can do all this PySpark in Google Colab with you don't need to do any kind of environmental variable, whatever, this, that, whatever. You could just, so there's a set of, and I do have it on my GitHub, which I posted on the comment section, where there's a file that should say config, and you bring that, you just run that code in the beginning. So what you're seeing here is a lot more than what I have in a note file. What you need is what's in the note file. What you're seeing here is just a little bit of extra stuff, which you don't need. So here, yeah, you run this top portion. This is another portion here. Yes, and it does says JDK 11, not 8. So here we're setting, directing your environment to these specific locations. All right. So this is something like your environmental variables-ish, but this is Google Colab. So here, so this block of code here is my attempt to create an app for you to see, but it was really difficult, and doing Google Colab is kind of challenging.
That
Yes.
original.csv, I didn't see it when I went into Colab. Is it?
Oh.
On
that-
mine, I don't see it when I went into Collab, and I have
Right.
the sample data folder. I just don't have that original .csv. I was playing around with the other sample data.
that should be in my GitHub link. The original .csv, or you can Google that CSV file. It should be available somewhere. So it's more like a teaching demo type of file. But yeah, that's what I was.
I was wondering if anyone else couldn't find it.
Oh, okay. Yeah, it should be on my GitHub, I hope.
I don't see it. I don't see the form.
It is not, yeah.
It's not.
It's not.
Oh, it's not? Okay. I'll upload it after this.
Cool. Thanks.
Okay, so yeah, so we have here importing. Actually, you know what? I could, since a lot of people are here, we could, let me go ahead and put that in my GitHub. Right. Yeah, so 100 years ago, I was an economist and converted data scientist.
Maybe while you're doing that, Mike, the question of optimization, I don't know, Mark, you might have a comment on this, is like, when I think about this stuff, I think like SQL, and in SQL there's, because the schema is so known, the database can have a query planner, which can help you figure out like, oh, am I gonna use this column or that column, which index am I gonna use, and so on and so on. With DataFrames, it doesn't seem like enough type information is there to really make those calls. It's like, so does anybody know how optimization, what that looks like with using these kind of tools?
Well, there is an optimizer, and you can do explain plan.
Okay.
And it'll show it to you. There's an explain method. And you know, there's, like I said, with DataFrames, like you said, with DataFrames, there's a schema, right? So it does know a fair amount about it. I mean, I guess with, if you're purely unstructured, it's hard to, if you start drilling into like an unstructured element, there's work to be done just to get it structured so you know what to do, right, for optimization. But then in that case, it's not really, and there's all kinds of storage options too for how you lay the data out, and you've got options for how you want to spread things out, and I'm trying to remember the term for that, like.
I know like you can do like in Postgres, just thinking about things that I know more about, like if you have JSON data, you can do a JSON meet column, and then you can add a certain gin index to it or something. It's going to figure it out because it knows about JSON. It's just like just curious about like what kind of tools or what indexing it does on these things.
I remember the indexing with this. I'm trying to recall. I keep looking to refresh my memory here from.
All right, let me see here.
Because it seems like a hard problem. This stuff's like all distributed. An index is in a singular database. The reason why it works is because you have an index as a singular, essentially binary tree or some kind of tree that it can navigate when you chop up your data.
There is indexing. There is indexing with this.
There we go.
It's not just freeform stuff, randomly thrown across the cluster, distributed.
Where's this at? Oops.
Well, Mike, just curious, how much more did you want to try and do here? Did you cover most of the things you wanted to cover?
I did cover most of the things I tried to cover. I was just wanting to go through just some of the Google Colab stuff. But yeah, the Google Colab stuff is very simple. But let me just, it's in here for everyone.
Yeah, I never
Cool
used
jobs.
Colab, it's kind of cool.
Yeah.
Yeah,
Yeah, you
it's
can
kind of amazing.
I like it.
Yeah, it's great. All right, it's in there now.
That's pretty good.
And
All right.
people can share it, so you can be like on a Zoom call.
Yeah,
Yeah.
yeah, exactly.
Is it basically just Python notebooks online?
Yeah.
Yes,
You just
yeah.
pull it up, and it's,
Just
you
pull it
just
up.
type in the GitHub link and it's there.
Well, you can't do too much on Google Colab.
Right.
you
I'm
still
sure.
can do enough.
But it's cool for like exactly what you're doing.
Yeah, yeah.
And then I'm sure you can start paying them.
Yeah, well, you're not gonna run like full systems,
Yeah.
production environment.
Okay, so we're back at Google Colab. The file should be there. Hopefully, we was able to overcome that little barrier there. So next, I just want to show some simple functions that I use on day-to-day that could help you if you decide to continue on this journey with using PySpark. So definitely something that I use a lot is to checking the data types when I'm working with different files and importing them. And especially when I'm importing data that I'm not familiar with, because I don't know how they're going to turn out to be in my session after importing it, so I want to check it. So this is one of the options that I would do is D types. That's just one of them, and we see that it gives us a lot of great information of what each column's data types is. Okay. We also have this option here. We could show some initial information. The head function, this is obviously something that we all know about. Here, here we go. First, yeah, showing the first one. Next, if you just want to view your columns, the names, just use .columns, and that will show that to you. And scrolling down. Yeah, and yeah, just wanted to see some additional information here. With column, we have a clean city. So this is when we have a conditional statement. When that city is null, we put unknown. Otherwise, that here, and I'm just wondering if that, yeah, here we go. We could perform a little data cleaning here. So those are options that we could consider. Count. This is an action. This is my favorite function. I use this every day to check my tables because a lot of times you can't like look at all the data on your table. You need like something quick because you got to get going, right? Count's a good way. But if you're at a point where you need to like start checking your data to see what's going on, you definitely need to display your information and do a visual
Get
inspection.
a rough idea if it worked.
Right.
Like a sanity
Yes.
check.
Did it work?
Yes,
Did it do
exactly.
something?
We're on the same page. Thank
Alright,
you.
cool.
Yeah. Yeah, unique rows. We got that here, distinct. And what else is there? Let's see here. All right.
What does it mean when you say distinct by itself?
Do some cleaning up top here. So there's different options here. Drop NA, social count. Let me see here. Oh yeah, that's right. We did drop some null values. We have our count. We see that from 1,000 went to 997. And yep.
So these are all things on PySpark's version of DataFrames? Is that what it
Yes,
is? Okay.
DataFrames, specifically DataFrames. So all what you see here is just DataFrames. But these are just some useful functions. And you can play with these when you get home. It's on my GitHub. And just try it out and see how it works for you. And there's lots of different, if you're in this environment, you're using PySpark, these different functions could help you save a lot of time. And this is what I've used and what I've grown to love, actually.
Cool.
Yeah. Okay, so I guess I'll just, there's another one, drop duplicates. This is really good, and I think I'll leave it at there. And yeah, any questions about today?
I'll just make one last comment that we talked a little bit at the beginning about Databricks, right? And there's cloud implementations of all these things on all the
Yes.
platforms. Like Microsoft has Synapse and Fabric, and they've got their PySpark, Google has theirs, Databricks is cloud agnostic, but it's a powerful
Bless you.
thing, and they all add significant features on top of the core PySpark that really makes it, I think, easier to get into.
Yeah.
If can work in maybe if you're in a cloud environment like that. So.
Cool. Any other questions for Mike?
All right, so we went over.
Thank you, Mike. Thank you.
Thank you very much.
Thank you.
All right, y'all.